Now we start off chapter 9, lesson 1 with this warm-up. Now I don't always show you the warm-ups, but there's a few reasons for including this one. First of all, to remind you rules of exponents, so anything to the power of 0 is just going to be 1. Anything to the power of 1 is just going to be the term itself, so x plus 1. Now if I give you squared, that means x plus 2 times x plus 2, so there's your FOIL question, so x squared plus 4x plus 4. And then as we get further down into the powers, we'd have to work out x plus 3 times x plus 3, which is x squared plus 6x plus 9. But that's only multiplied together twice, so you've got to times by another x plus 3. So when you work this out, you have to do x squared times x squared times 3, 6x times x, 6x times 3, 9 times x, and 9 times 3. Notice that the number of terms here, 3 and 2, 3 times 2 is 6, and I do have 6 terms here. Now I line these up deliberately, so when I combine terms, this is going to be quicker to do. So 9x squared, 27x, plus 27. And you can see that question took quite a long time, and if I'm going to do it to the power of 4, it's going to take me even longer to do, excuse me. And if I go up to the power of 7, then it's obviously going to take a much longer time to do it again. So there is a shortcut for this, and that's actually what we're going to look at in today's lesson. So today's lesson is the binomial theorem, or specifically the binomial expansion. And what we're going to look at in our first lesson is to be able to expand 2 terms to the power of n, binomial, 2 terms, when n is small. Now, pretty vague, but basically I'm thinking of terms under 10. And in lesson 2, we'll look what happens if n is large, so in other words, if it's greater than 10. Now, first of all, what we're going to look at is something called Pascal's Triangle. And hopefully you can notice a few things here. First of all, the outside diagonals are 1. The second diagonal is just your counting numbers. And actually your third diagonal, will be more obvious once there's a few more numbers here, this is actually your triangular numbers. Now, there are other patterns within Pascal's Triangle as well. If you read it forwards, that's the same as reading it backwards. In fact, if you add the rows together, numbers in each row, 1, 1 plus 1 is 2, 1 plus 2 plus 1 is 4, 1 plus 3 plus 3 plus 1 is 8, and actually it keeps doubling. This number is actually 11 to the 0, 11 to the 1, 11 to the 2, 11 to the 3, 11 to the 4. So there's lots of patterns in here. Now we know that this number here is going to be 1 because it always starts with 1. To find the next number, you add the 2 numbers directly above it. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, we know the last number is going to be 1. And then the pattern continues, so this would be 15. And once we've got to halfway, we know the pattern repeats, so we can just go 15, 6, 1. And we're actually going to use that to help us find the answer when we need to do the binomial expansion. So make sure you know how to write out the first few rows. You don't necessarily need to put the hexagons around it. If you sort of set it up in that format, then that will suffice when we answer our questions. Now let's start actually answering a question. So x plus 4 to the power of 3. Now the first thing I'm going to look at is this power here. And I'm going to look for the row of Pascal's triangle where the second number is 3. Obviously the first number is always going to be 1. So if you look at your picture, then you should find out that it's going to be 1, 3, 3, 1. Now deliberately leave spaces like this as well, because when we construct our answer, what we're going to do is we're going to do 3 different things. So first thing we're going to do is write out the numbers from Pascal's triangle. Second thing we're going to do is we're going to take the first term and do it to this power. Now I'm going to put parentheses around it, which is not necessarily for x, but if it was something like 2x, then that would be quite important. And then on each term, I'm going to do the same thing, but I'm going to decrease the power by 1. So this was 3, so I'm going to go 2, power of 1, power of 0. And then I take the last term, which is 4, and I'm going to do the same thing, but I'm going to do the reverse order. So I'm going to do 4 to the 0, 4 to the 1, 4 to the 2, and 4 to the 3. Now I'm using different colours here, just so you can see exactly how we're putting this together. So leave some spaces so you can always construct your answer in this way. Number from Pascal's triangle, first term to some power, second term to some power. The other thing you should notice here as well is if you add these 2 numbers together, you're always going to get the power that's in the original question. So 1 plus 2 is 3, 0 plus 3 is also 3. Then we start to evaluate all this stuff. Now anything to the power of 0 is just 1, times by this one is just 1, so actually we just get x cubed. And you can always find the first term by just taking this first term and then doing it to this power. Now within here, 3 times 4 to the 1 is 12, times by x squared is 12x squared. 3 times 4 squared is 48. X to the 1 is just merely x. X to the 0 is 1, times 1 is 1, times 4 cubed is 64. And the last term we could just have got by taking the last term and cubing it. What you've got to be careful is you don't try a distribution method and say it's like x cubed plus 4 cubed, because you would miss these middle two terms. And you can check that by using the method you used earlier as well, if you want to see if that does indeed agree. Now you might want to try this second question for yourself, first of all. So you might want to pause the video at this point. So this question is 2x minus 3 to the power of 4. So power of 4, look for the row Pascal's triangle that starts with 1 and then 4. Notice again I've left some spaces here in between. And then I can start to fill in some of these answers. So I'm going to do 2x to the power of 4, 2x to the power of 3, 2x to the power of 2, 2x to the power of 1, and 2x to the power of 0. Negative 3 this time, so negative 3, but I'm going to go the reverse direction. Power of 0, power of 1, power of 2, power of 3, and power of 4. Notice again that the two powers together in any term should add up to the same number as the power in the original question as well. We know that these terms are both going to be 1, so 2x to the power of 4, and this is where you've got to be careful. 2 to the 4 is 16, x to the 4 is x to the 4, so 16x to the 4, and not just 2x to the 4. 2 cubed is 8, times 4 is 32, times negative 3 is negative 96, x cubed. Negative 3 squared, be careful how you enter on your calculator. If you put this, then it's going to do order of operations first and get 9 and then make it negative. So another good reason we put in parentheses around this. So negative 3 squared is 9, times 2 squared, times by 6. And that's going to give us 216x squared. Negative 3 cubed is negative 27, times 4 is negative 108, times 2 is also 216, but negative. And for our last one, this is both 1, negative 3 to the 4 is 81. Now one other little check for you when you're doing these questions, any question where we have a negative sign, then this should actually keep flipping from positive to negative to positive to negative to positive. So one little extra check you can do to see if your answer is indeed correct. Now there is a short version of questions where instead of asking you to find the whole expansion, they're just asking for a specific coefficient. Now you could work out the whole answer and then just take x cubed, but that's rather inefficient. So what we're going to do is, we can see it's the power of 4 here. So I know I'm going to be using this row of Pascal's triangle. Now if I was to do this question, I would start with x to the 4, x to the 3. And actually that's what I'm interested in for this question. So this is really the key term for this one. So my answer starts with 4, because that's the number from Pascal's triangle. I then have x to the power of 3. And I also know I'm going to have positive 5 to some power as well. And remember the rule is that the two powers must add to the power in the question. So this must be a 1. And then I can actually start to work this out. So 4 times 5 cubed is 20. So I have 20x cubed. As the question just says what's the coefficient, then we can just say the answer is 20. So a slightly longer question this time, because we're going up to the power of 6. Also I've got a negative in here, and rather than just x, I've got 3x here. So I'm going to start by looking at the row of Pascal's triangle that starts with 1, 6. And if I was to start doing this question, then I would do 3x all to the power of 6, 3x all to the power of 5, power of 4, power of 3. So 20 is the number that I'm interested in with this question. So I'm going to start with 20. I'm then going to do my first term to the power of 3. My second term also to the power of 3, because 3 plus 3 equals 6. And then I can start to work out what all these things are. So 3 cubed, negative 2 cubed. And then when I can combine the answer, I'm going to ignore the x cubed, because coefficient just means how many of that term do I actually have. Okay, last question, this time with two variables, so x cubed and y to the 5. So it's the power of 8, so we're going to need the 8th row to begin with. And if I was doing this, I'll be doing 4x all to the power of 8, 4x all to the power of 7, 6, 5, 4, 3. So I'm interested in 56 for this question. So 56, first term to the power of 3, because that will give me my x cubed term. Negative y, the second term, it's got to be to the power of 5, because 3 plus 5 is 8. But also you can see in the question here, y to the 5th, y to the 5th. Multiply this out, so 4 cubed is going to give me 64. Got a negative sign here as well. And when we multiply out, we end up with that. So certainly for a question like that, you wouldn't want to work out the whole question. So just use that little trick to figure out exactly which part's needed, and then you can work out the answer much quicker.